Hello everyone, welcome to the second part uh, of this video which deals about the conceptual problems of solid geometry. The first part of the video we discussed the five conceptual problems that deals the basic concepts of solid geometry. In this video, we'll discuss another five problems that will help you to make certain concepts to crack your entrance examinations for the intermediate level. So here's the first question, which says that a cone is inscribed in a cube of volume 1 in such a way that its base is inscribed in one face of the cube. What is the volume of the cone? We have the option 0.21, 0.26, 0.33, 0.42, 0.67, right? This is our question. So in this question, cone is inscribed in a cube, right? So cone is inscribed in such a way that you can see that circular base area of the cone is totally inscribed in the face, right? In one of the face of the cube, which is the base of the cube as well, right? So for this question, you can see in the figure, right? So base of the cone, it's inscribed in the base of the cube, right? Which can give you a concept that the diameter of the circular base of the cone will be equal to one of the edge of the cube, right? So basically L will be equal to the diameter of the cone. And another thing is that the top point of the cone, it's totally on the surface of the top side of the top face of the cube, right? The point of the cone is it it lies in the top face of the cube, right? So basically the height of the cone will also be equal to one of the edge, right? Height of the cube, right? One of the edge of the cube, because all the edges of cube they have equal value. So basically when you label each edge of the cube as L, then obviously this height of the cone will also be equal to L, right? So I wrote this value as H to make it clear that the height of the cone will be equal to the edge of the cube, right? So talking about this problem, so volume of cube is given 1 in the question. So you can look at here. So volume of cube is 1. So you can say that when the volume of cube is 1, so L cube equals to 1. So that's basically we don't deal with negative integers when you are dealing with solid geometry. So obviously L will be equal to 1. So when L is equal to 1, we can see that the base of the cone, right, its diameter is equal to the age of the cube. So that will be L divided by 2, because diameter when divided by 2 will give you the radius, right? So it's L divided by 2. The diameter it's 1, then when you divide it by 2, then you'll get the radius of the circle. This circle means the base area of the cone, right? Radius of the base area of the cone is 0.5. So height of the cone, it will be equal to the edge, one of the edge of the cube, right? Since it's top of the cone, this top point of the cone, it lies in the top surface of the cube. So that means the height of the cone will also be equal to the height of the edge of the cube. So question has asked the volume of cone, right? So volume of cone, that is the formula for the volume of the cone is 1/3 pi r square h. So for 1/3 it's constant, pi you have certain value, for radius we have calculated it as 0.5. So 0.5 whole square, and the height will be equal to 1, right? So height when equals to 1, then you'll get the value 0.2617 when you calculate the formula for the volume of the cone, right? So here's the next question. In this question, if a solid right circular cylinder, right, with a height 9 and radius 2 is cut as shown into 3 new cylinders, each of equal and uniform height, how much new surface area is created? So our options are 4 pi, 12 pi, 16 pi, and 24 pi. So basically this question says that you have given a cylinder when you cut it into 3 equal parts, right? Or into 3 new cylinders. What are the new surface area created? So basically in our original figure, we already have the 2 surface area, this top one and this base area, right? This won't be counted when you find the value of surface area for these new parts, 3 individual parts, because this part and this part, the base top part of the cylinder and the base part of the cylinder shouldn't be counted when you take out the new surface area that is created when you make the single cylinder into 3 parts, right? So here in figure you can analyze that this red portion part, it already exists, right? This is the old base area, surface area of the cylinder, so you don't need to calculate or keep consideration what's the base area of these cylinder. You don't need to add this both surface area, but you just need to find the new surface area that is created due to uh, when you cut the single cylinder into 3 parts, right? So this green shaded part, it's a new created surface area. This both rated part, they are already in the cylinder before you cut it down into 3 parts. So when you cut into 3 parts, this first surface area, this is second surface area, this is third surface area, and this is fourth surface area. So generally 4 new circular surface area is to be considered when you cut a single cylinder into a 3 parts, right? Question has asked you the new surface area that is created when you cut the single cylinder into 3 parts. So generally for each surface area, you just have formula pi r square, right? The radius of the cylinder, as mentioned in question, it's given 2. So when you take out the value, then each surface area will give you value 4 pi, right? So the surface area, the value of surface area, it's 4 pi. So when you cut in single cylinder into 3 new parts, then you have 4 new surface area, right? 4 new surface area are created. So when you multiply these each surface area by 4, then you'll get 4 pi, that is 16 pi is your new surface area. And when you look at the option, you have C, right? It's 16 pi is your answer. So here's the another question. That is, a 5 feet long cylindrical pipe has an inner diameter of 6 feet and outer diameter of 8 feet, right? If the total surface area inside and out, including the ends, right? Inside and out, including the ends, is k pi, what is the value of k? So we have the option 40, 48, 70, and 84. We have 4 options. So that's looking at the question, you may not be clear. So I have drawn a figure here that can give you some insight. So generally, when question has mentioned to you that the pipe has inner diameter of 6 feet and outer diameter of 8 feet, right? So you can see in the figure. So outer diameter means from the center of this base, the up to this exterior part, right? When the diameter is 8, you can divide its diameter into radius 4, its exterior part, and it has inner diameter, right? Since it's pipe, the void part, it's hollow, so it's 6 the diameter, the inner diameter it's 6. So you can split the radius into 3 and 3, right? When you divide by diameter by 2, then you can write 3. The radius of the inner circle is 3, right? And it has mentioned that this pipe it's 5 feet long, right? So this is the figure. I hope you got the question, or you got the concept of the diagram as described in this question. So if the total surface area, so what this question asked actually is, if the total surface area inside and out, right, including the ins, is k pi, so what is the value of k? So generally what a question has mentioned use that let us take out the curved surface area, right? Curved surface area of the cylinder. First, let's take out the curved surface area of the exterior part, this exterior part, right? So exterior part, the curved surface area, the formula for curved surface area is 2 pi r, yes, right? So 2 pi r, it's a circumference of the circle. So when you multiply it with the height, then you'll get the curved surface area of the cylinder, right? So similarly, for exterior, right, exterior part, when you find the curved surface area, that will be 4 pi, because 2 pi r radius is 4 for the exterior part, and for height will be 5. So 2 pi r is, that will give you 40 pi, right? So again, the question has asked you about the curved surface area for the, right? Let's look at the question. So if the total surface area inside and out, so we have calculated the outside surface area, this 45, it's our outside surface area. So it has inside, right? So for inside curved surface area, so you know that the inner diameter, so what's the inner diameter? It's 6, right? So I split it, its radius as 3. So for inner curved surface area, you can write 2 pi r as 2 pi, and then radius is 3 and s is 5. So that will be 30 pi, right? The inner side curved surface area. So again, let's get here. Let's understand the question. If the total surface area inside, right, and out. So outside it's 40, right? Outside curved surface area it's 40, 4 pi. So it has say inner, right? Inner side. So inner curved surface area it's 30 pi, right? So again, at last, this total surface area, it consists the curved surface area of inside part, and it's it consists outside part, and at last including the ends, right? Including the ends. Since you can see this white shaded part, it's the hollow part of the cylinder, right? We don't need the area of this white part. We just need the area of the green shaded part of this pipe, which we can get by the differentiation between the inner surface area and outer surface area of the base of the cylinder. For outer surface area, we have radius 4, and for inner, it's 3. So when you differentiate the area between the outer surface of the cylinder and inner surface of the cylinder, you can get the green shaded part of this diagram. So here, so base for base area exterior, that is pi r square for the base area of the cylinder, which is circular. So radius it's 4, outside part it's 4. So you'll get 16 pi And again, for interior part, it's pi squared by 3 squared, that is 9 pi, because the inner radius, that is 3. So as I mentioned, when you differentiate these two areas, pi minus 9 pi, you'll get 7 pi, right? 7 pi is your green shaded area of the cylinder, right? So it has a question has asked both ends, right? Curved surface area of exterior part, interior part, and the uh, circular part, right? Circular part in the both ends. So circular part in the both ends means at one end it's 7 pi, and another end it's another 7 pi. So our question, it has mentioned that when the total surface area of inside out, right, both curved surface area and including the both in, it is k pi. So what is the value of k? So when you, for exterior curved surface area, that is 40 pi, interior curved surface area, that is 30 pi. So when you add, that is 40 plus that is 70 pi. And again, when you add 7 pi for one base and 7 pi for another base, you'll get total of 84 pi. So our question, it has mentioned that the whole area, adding the both curved surface area, interior, exterior, and both the ends, it will yield k pi, and we have got 84 pi. When you calculate, we got the value 84 pi. So when you compare 84 pi with k pi, pi will get cancelled, and k is equal to 84, right? So k is equals to 84. So when you check our option, that D is the correct answer. Okay. So here's the another question that tells us that a rectangular tank has a base that is 10 centimeter by 5 centimeter and height of 20 centimeter. So in the tank, if the tank is half full of water, right? So it's half full of water. By how many centimeters will the water level rise if 325 cubic centimeters of water are poured into the tank? Right? We have rectangular tank. Its base is 10 centimeters by 5 centimeter. Length is 10 and breadth is 5 centimeter. So total height it's 20 centimeter. So if the tank is half full of water, by how many centimeters will the water level rise if 325 cubic centimeter of water is poured into the tank? So basically this question just tried to fool us by giving the information about 20 centimeters, because it had just asked you that what is the rise in water level if 325 cubic centimeter of water is poured into the tank, whether it's half full or not. We don't care about the height, that is 20 centimeter. We just need to find the height that gets rise when you pour the 325 cubic centimeter of water into the rectangular tank, right? So let's see the picture first. So this is the picture, since I have mentioned the height, so because it's given in question. So base is 10 by 5. So basically the area of the base of the rectangular tank, it's 50. All right. So maybe it's half full. So I just mark this red circular line. So maybe if it's half full, then this height can be 10, because total 20-meter height of the rectangular tank, when it's filled in half, then it will be 10, right? So I just marked it. But I don't think that we need to care about the given height or the information that it's half filled. We just need to calculate that the area of base, that is 10 into 5, is 50 square centimeters, right? So for the concept of depth, right, so volume 1 centimeter depth has 50 cubic centimeter of water. So what I basically want to tell you that if the area of the base is 50 centimeters square, right? So 1 centimeter of height, right? So it's base, and if you fill the base with let's say 1 centimeter height of water, then the 1 centimeter of height, it contains 50 cubic centimeter of water in 1 centimeter height. Let's understand here. You have base that is 50 centimeters square, right? So when you pour the water in height just as level as 1 centimeter, then how much water does this tank occupy? That is 50 centimeter cube of water in 1 centimeter of height. So question, it has mentioned as that it has poured 325 centimeter cube of water in this rectangular tank. So 1 centimeter height, it consists of 50 centimeter cube of water. Then if you pour 325 centimeter cube of water, then obviously when divide this 325 centimeter cube with water with 50 centimeter cube, right? Because 50 centimeter cube is the volume of water in 1 centimeter height of this rectangular tank, right? So this logic can help you to crack the height, right? That is to be found in this question. So when 325 centimeter cube water is poured, then raise in water level can be as 325 centimeter cube of water is poured. Since 1 centimeter cube, it consists of 50 centimeter cube of water. 1 centimeter height contains 50 centimeter cube of water, since its length and breadth is 5 and 10, right? So when you divide 300 centimeter cube of water by 50 centimeter cube, you'll get the height, that is 6.5. So that means we don't care whether it's half full or it's fully full. The question, it has asked that what will happen in this tank when you pour the 325 cubic centimeter of water. So when you pour 325 cubic centimeter of water in this tank, then obviously it will gonna rise up to 6.5 centimeter in height. So you just need to divide 325 by 50, so you'll get your answer 6.5 centimeter. uh, that is option D. Okay. So here's the last question for today. That is, three identical balls fit snugly, right? It's tightly fit into a cylindrical can. The radius of the sphere is equal to the radius of the can, right? The radius of the ball and the radius of can, it's equal. And the ball just touch the bottom and the top of the can. This figure may not be up to scale. I just tried my best to make you understand. So what fraction of the volume of the can is taken up by the balls? If, right, so I just missed this part, that tells you that if the formula for the volume of the sphere is V equals to 4 by 3 pi r cube. So student, you have to know the formula. Since it's given in this question, it may not be in other questions, so you need to know this formula by heart when you deal with the inference level questions. So this is the three balls that is inscribed in this cylindrical can. So question is asked, what is the unused space or unused volume inside the can, right? That hasn't been occupied by this ball, right? And this part, this white part, right, which isn't occupied by the ball. You need to take out the volume of that unused part or unoccupied part by these spherical balls. So let's see here. So when you see in this question, so I just draw a figure here, the three balls, it's in the cylindrical can, right? So this is the radius. So what happens is that from this point to this point, right? It's radius of the sphere, so it's d. What we know that radius of the sphere and cylinder is same. It's mentioned in the question. So this from this point to this point, right? It's the diameter of the sphere. Let's say it's d. Similarly, from this point to this point, same. The diameter of shape. Since three balls, they are equal, right? So height of the cylinder can be written as 3d plus d plus d, that is 3d, right? The height of the cylinder can be 3 into d. Since 3 diameter, when you add 3 diameter of the ball, you can get the height of the cylinder, right? So volume of the ball when radius, uh, for this question, since radius it's not given, right? In question it's not given. So what I did is that I assumed let the radius be 1, so that my calculation can be easier, right? You need to suppose the value r, that is 1, right? So when you suppose the value of r as 1, so what happens is that the volume of ball 4 by 3 pi r cube, you'll get as 4 by 3 pi 1 cube, so that would be 4 by 3 pi, that is the volume of the ball. You can get the volume of the ball, right? So total volume of 3 balls, right? 3 into 4 by 3 pi, that will get, you'll get 4 pi. When you multiply 3 into volume of each ball, you'll get the value 4 pi. So that is the volume of 3 balls that is shown in this figure, which is inscribed in the can, right? So for can, the diameter of each sphere, since I suppose the radius is 1, so diameter of each sphere is 2, right? Diameter of each sphere will become 2. So height of the can will be 3 into diameter of sphere I have shown in the figure, right? From this point to this point, one diameter. From this point to this point, another diameter. Then this point to this point, another diameter. So when you add, so it will be 3D, right? 3 into diameter of sphere. So diameter of each diameter of sphere will be 2, because I have supposed radius as 1. So that will be 6, right? Height of the can, that will be 6. So volume of can is, what is the volume of the can? Volume of the can is pi r square h, right? Whole volume of can, that is pi r square. The base is pi r square, and when you multiply base with height, then you'll get the volume of the cylinder, right? So pi r square h, that is 6 pi. So volume of 3 balls, that is 4 pi, and volume of whole can is 6 pi. So again, we'll take a look at the question. So what fraction of the volume of the can is taken up by the balls? So what fraction is occupied by these balls, right? So for taking out the fraction occupied by 3 balls, you just need to know the basic concept of fraction, that volume taken up by balls can be calculated if you take out the fraction of volume of balls upon volume of can, right? So total volume, obviously the volume of can is bigger than the volume of 3 spheres, right? Because there are some unused space in the cylindrical can. So volume of balls upon volume of can, that is 4 pi upon 6 pi. So when you simplify it, you'll get the answer 2 by 3. Since there's no option, so value for this question is 2 by 3. So I think this much for today. So I'll be back with some more conceptual problems in my next class. Thank you for listening. Have a good day.